All right, let's talk about something that is pretty much reshaping our entire world, often in ways we don't even see: machine learning. I mean, it's the magic behind everything from your Netflix recommendations to self-driving cars. But how does it actually work?
I mean, that's the real question, isn't it? For decades, computers did exactly what we told them to do, step by step, with rigid lines of code. But now, all of a sudden, we're in this new world where they can, figure things out for themselves. So how on earth is that even possible?
Well, the secret sauce here is machine learning. It's this branch of artificial intelligence where, instead of writing out every single rule, we just flood the computer with a ton of data and let it find the patterns on its own. It's really all about learning from experience, kind of like how we humans do it.
To really get this, it helps to stop thinking about it as programming and start thinking of it as teaching. And this teaching process, it follows 4 pretty basic steps. Probably the best analogy is to imagine teaching a little kid how to tell the difference between a cat and a dog. You wouldn't write down a giant instruction manual, right? A cat has pointy ears, whiskers, a long tail, no way. You just show them a bunch of pictures of cats and dogs. That's the core idea.
So this whole education breaks down into 4 key stages. First, you've got to get the study materials. That's the data collection. Then, the real classroom session begins. That's training the model. After that, it's test time, making predictions. And finally, and this is so important, it grades its own test and learns from its mistakes to get better. So let's look at each of these.
Okay, step 1. Every single journey in machine learning, and I mean every one, kicks off with one absolutely essential ingredient: data. Think of it as the textbooks, the photos, the homework problems for our digital student. Without the raw material, there's just nothing to learn from.
And this data can be pretty much anything you can think of. It could be millions of images, huge libraries of text, decades of stock market numbers, or even just the subtle ways you click around on a website. But here's the thing: quality is everything. There's an old saying in this field: garbage in, garbage out. If you feed a machine messy or biased data, you're going to get messy or biased results.
Yeah, this really just drives the point home, right? Just like a student needs a good library to do their research, a model needs a massive, high-quality data set. And generally speaking, the more good examples it gets to see, the smarter and more sophisticated its understanding becomes. All right, so we've gathered all our study materials. It's time for class to begin. And this brings us to the second and maybe most important phase: the actual training. This is where the learning really happens.
During training, the machine is basically just digging through mountains of that data looking for patterns. So with our cat and dog pictures, it might start to notice that pointy ears and whiskers often show up with the label cat. It'll make a guess, check if it's right, and then tweak its own internal logic just a little bit. Now imagine that process repeated millions or even billions of times. Each little adjustment makes it a tiny bit better. And what's wild is that sometimes we don't even know how it's making these connections. It's often called the black box problem. We see what goes in and what comes out, but the thought process inside can be a total mystery.
So after all that training, all that studying, the model basically graduates. It's finally ready to be tested on brand new information that it has never, ever seen before. This is where we get to see what it's learned. And the results are literally all around us, every day. That trained model is what lets your phone recognize your face to unlock. It's what suggests the next YouTube video you just have to watch. And it's what keeps your email inbox from being a total disaster by filtering out all that spam. It's taking its education and applying it to the real world. But here's the really cool part. Graduation isn't the end of the story, not even close. In fact, maybe the most powerful thing about machine learning is that this whole process is a continuous loop. It never stops getting better. Think about it this way. When your spam filter messes up and puts an important email in the junk folder, what do? You move it back to your inbox. Well, you just gave the system feedback. You basically became the teacher. The system sees that correction and learns, okay, got that one wrong, and it refines its rules for the future. It's a constant cycle of improvement. Okay, so we've got the basic 4-step process down, but it turns out there are a few different teaching styles, or curriculums, that we can use to train a model. There are 3 main ways to do it. So, first up is what we call supervised learning. This is where we basically give the machine an answer key. We feed it a bunch of data that's already labeled, like a million emails that are clearly marked spam or not spam. The goal is for it to learn the patterns so it can label new emails correctly. Then you have unsupervised learning. This is the total opposite. We give it a huge pile of unlabeled data and just say, find something interesting in here.
It becomes a data detective, finding hidden groups on its own, like discovering that online shoppers fall into 3 distinct categories without us ever telling it what to look for.
And finally, there's reinforcement learning. This one is all about trial and error. Just imagine you're training an AI to play a video game. Every time it makes a good move, you give it a little reward, like a point. Every time it makes a bad move, you give it a penalty. After playing millions and millions of games, it just naturally figures out the best strategies to get the highest score. This is exactly how AIs have learned to master super complex games, and even how we teach robots to perform delicate tasks. So all this technical stuff might seem a little abstract, but I promise you, this isn't science fiction. Machine learning is already deeply woven into the fabric of your daily life in ways you might not even realize.
I mean, every time YouTube or Netflix recommends a video that you actually end up loving, that's machine learning analyzing what you watch. That spam filter we keep talking about, that's a model at work. The products Amazon suggests, the route your map app takes, and of course, the incredible technology inside of self-driving cars, it's all powered by this.
Okay, so let's boil all this down. If you walk away remembering just one thing from this entire explainer, what should that one thing be?
Here's the most important takeaway. We have fundamentally changed how we interact with computers. We've gone from an age of programming them, where we had to spell everything out, to an age of training them. We've given them the ability to learn from the world's data and get smarter, better, and more helpful, all on their own.
And that leaves us with a really fascinating, kind of mind-bending final thought. We're creating these systems that learn from the sum total of our collective human experience, our data. The question is no longer just about what we can teach them. As they start to find patterns in science, in medicine, in art that we could never see for ourselves, what will they eventually teach us?